Good afternoon. We are going to learn how to graph quadratic functions. For the notes today, you will need a ruler, you will need graph paper. So if you don't have those out, pause the video, go ahead and get those out. And we're going to go over how to graph a parabola. So we're going to start with the body parts of the parabola. So here we go. Number one, we're going to be graphing in standard form, which for a parabola is f of x equals ax squared plus bx plus c. And of course, a can't be 0. So you'll notice this is a quadratic equation, and the name of the graph of a quadratic is a parabola. Okay, so number two, we can tell if the parabola is going to open up or down just by looking at the formula. If the number attached to x squared, the a, is positive, it means our parabola opens up. If the a is negative, it means our parabola opens down, and that will help us graph it a lot easier. Okay, number three, every parabola has a vertex, and there is a formula for the vertex. It is -1 times b over 2 times a. That will give you the x coordinate. Unfortunately, there is not a formula for the y coordinate, so you take the x and calculate it using the formula. Then you substitute it into the equation and solve for y. So you have to solve for the y. The vertex is the maximum or minimum of the parabola, depending on whether the parabola is opening up or down. Okay, the fourth structure that we look at when we graph is called the axis of symmetry. The axis of symmetry splits the parabola down the middle into two identical halves. The equation for the axis of symmetry is x equals -1 times b over 2 times a, which you'll notice is the x coordinate of the vertex. That's because the axis of symmetry passes through the vertex, but it is a vertical line. So the axis of symmetry is a vertical line, and you show it as dashed because it's not actually part of the parabola, but it is part of the structure of the parabola. Okay, so those are some of the body parts. Let's go to Roman numeral 2, graphing parabolas. All right, and example 1 that we're going to graph is f of x equals x squared plus 6x plus 8. All right, so just like when we do ABC factoring, the a term is the invisible 1 on the x squared, the b term is the 6, and the c term is the 8. Now in this equation, my a is a positive 1, so I know that my parabola opens upward. All right, let's find the vertex. So remember, the formula for the vertex is -1 times b over 2 times a, and then you solve to get the y coordinate. So here we go. Let's find the x coordinate. -1 times b, which is 6, over 2 times a, which is 1, is -6 over 2, or a -3. That's the x coordinate of the vertex. Now, to get the y coordinate of the vertex, we take the -3, we substitute it into the equation. Now, if you remember, f of x is function notation, but the f of x itself just represents y. So y equals, now we're going to sub the -3 in, -3 squared plus 6 times -3 plus 8. So do the exponent first. -3 times -3 is 9. Now multiply. 6 times -3 is -18 plus 8. And last you add them together and you get a -1. So we designate the vertex with a V, and it is -3 for the x, -1 for the y. All right, the last structure we're going to calculate and then we're going to graph is the axis of symmetry. So the formula for the axis of symmetry is x equals -1 times b over 2 times a. Now, there's a great cheat for this. This formula is the same as the x-coordinate formula, which we already know is -3. So x equals -3 is our axis of symmetry, and we don't have to calculate anything else. All right, come over here to the blank part at the right-hand side. Use your straight edge, and we're going to draw ourselves a pair of axes. You can scoot the y-axis over to the right quite a bit. And we're going to graph what we have so far. So far, we have a vertex, which is -3, -1. So 1, 2, 3, down 1. Label it with a V, -3, -1. Then we have an axis of symmetry that passes through the vertex. Use your ruler, line it up. It is a vertical line. It's dashed. Put arrowheads on it, and then put the formula at one arrowhead or the other. I'm going to go ahead and just put it at the top. X equals -3 is the formula, and put a box around it. So we know from our A that it's opening upward, but we need the points. When you graph a parabola, you need 2 pairs of points. 2 pairs of points. So let's make an extended H chart, and you're going to want to make it wider than you would for a line because there's a lot more calculating to do. Our formula is y equals x squared plus 6x plus 8. So we want to make a nice symmetrical figure. So when we pick our x's, we're going to pick them symmetrical. So if I go 1x to the left, that would be -4. If I go 1x to the right, that would be -2. Those are equidistant from the vertex, so I should get the same y value. But let's go ahead and sub these in. So I have -4 squared plus 6 times -4 plus 8. So exponent first, -4 times -4 is 16. Now multiply, 6 times -4 is -24, and now plus 8. And that equals a 0. Now if we did this right, I should get a 0 when I substitute the 2 in. So let's do it. -2 squared plus 6 times -2 plus 8. Exponent first, -2 times -2 is 4. Now multiply, 6 times -2 is -12, plus an 8 is also 0. So coming onto our graph, we have -4, 0, and we have -2, 0. And yes, you do need to label those points on your graph. All right, that's one pair. Now we need another pair. So if I go 2 to the left, I'm at a -5. If I go 2 to the right, 1, 2, I'm at a -1. And again, those are mirrored points, so that will help me know if my math is good. So let's try the -5. So -5 squared plus 6 times -5 plus 8. -5 times -5 is 25. 6 times -5 is -30. 25 minus 30 is -5. Plus 8 is a 3. Now, if this is right, I should get the same thing for the -1. So let's substitute the -1 in. -1 squared plus 6 times -1 plus 8. -1 times -1 is +1. 6 times -1 is -6, and then plus an 8. 1 minus 6 is -5. -5 plus 8 is 3. It came out the same. All right, let's plot this. So we're going to go -5 to the left, up 1, 2, 3. Label that. And -1 to the left, up 3. Now we're ready to draw our shape. And a good parabola shape is never pointy or angular. It's smooth, and the sides get gradually steeper, but they never quite get vertical. The sides are always going outward. They just go outward at a slower and slower pace. Okay, so required elements on a graph. You've got to have the vertex, you've got to have the axis of symmetry, and you need to have two pairs of points. Those are the things that need to be present on a graph. All right, we're going to flip the page and we're going to try another one of these. This time we'll try one that's opening downward. All right, so this is example 2. We're going to do f of x equals negative x squared plus 1. Okay, so you notice it doesn't have an x term. So if you want to think of this a little differently, f of x is really y. This negative, remember there's no such thing as a negative without a 1, so that's negative 1x squared. I don't have an x, so I'm going to fill with a 0x. Plus a 1. So your A is negative 1, your B is 0, your C is 1. Okay, our A value is a negative 1, which is negative, so that means that our parabola opens downward. So when it comes time to make the parabola, we need it to go downward. All right, we're going to do the vertex. Remember your vertex formula is negative 1 times b over 2 times a, and then you have to substitute in and solve for the y. So for the x coordinate, here we go. Negative 1 times b, which is 0, over 2 times a is negative 1. That gives me 0 over negative 2, which is 0. Now the y coordinate. I'm going to take the 0 and substitute it in and simplify to get the y. So we go negative 1 times 0 squared plus 0 times 0 plus 1. And of course 0 times anything is 0, so we just end up with a 1. So our vertex is 0, 1. All right, this means that our axis of symmetry, which remember has the equation x equals negative 1 times b over 2 times a. This is the same as the x coordinate of the vertex, which is 0. So my axis is x equals 0. Okay, grab your ruler. And we're going to draw ourselves a pair of axes. Now this is opening downward, so you can scoot your your x-axis pretty far up because you know most of the shape is going to go downward. All right, let's plot the vertex. 0, 1. So mark it with a V and 0, 1. Now, when your axis of symmetry cuts right down an axis, what you have to do is offset your ruler just slightly so that when you draw your dashes, you can still see them. And this is the line x equals 0. Okay, so we have our vertex, we have our axis of symmetry, we know this opens downward. We're ready to find our points. So go ahead and make your extended H chart. Remember, it's going to be a lot wider than for a line. Your formula is y equals negative 1x squared plus 1. And now let's pick our points. I pick 1 to the left, 1 to the right, so that would be negative 1 and 1. Those two should be the same. If I go 2 to the right, 2 to the left, that would be 2, negative 2, and those two should be the same. So we're going to substitute those into the equation and get the y's. So here we go, negative 1 times negative 1 squared plus 1. So you've got to do the exponent first. So this part goes first. Negative 1 times negative 1 is positive 1. So now I've got negative 1 times 1 plus 1. So we did the exponent. Now we multiply. Negative 1 times 1 is negative 1. And last you add and you get a 0. Now if we did this right, we should get the same thing with a 1. So here we go. Negative 1 times 1 squared plus 1. Again, you've got to do the exponent first. 1 times 1 is 1. Once you've done the exponent, now you multiply. Negative 1 times 1 is negative 1. And last you add, and you get a 0. Let's put those on our graph. We have a 1, 0, and a negative 1, 0. And yes, it looks like our points are going in the correct direction. All right, let's do the 2's. Here we go. Negative 1 times 2 squared plus 1. Do the power first. 2 times 2 is 4. So I have negative 1 times 4 plus 1. Now we multiply. Negative 1 times 4 is negative 4. And negative 4 plus 1 is negative 3. All right, let's check ourselves by doing the negative 2. Here we go. Negative 1 times negative 2 squared plus 1. Do the power first. Negative 2 times negative 2 is positive 4. Now you multiply. Negative 1 times 4 is negative 4. And negative 4 plus 1 is negative 3. All right, let's put that on our graph. 2 to the right, 1, 2, 3 down. So 2, negative 3. 2 to the left, 1, 2, 3 down. Negative 2, negative 3. Draw your parabola nice and curvy. The sides never quite go straight. Put the arrowheads on them and you have a parabola. All right. The last thing we're going to go over on the notes is a little bit about graph shape. One of the hardest parts about graphing parabolas is knowing when you're getting off. Like, when is your graph not correct? So let's say here's your graph, y equals ax squared plus bx plus c. Okay, there's 3 basic shapes that you're going to run into. The first one is if a equals 1 or a equals negative 1. So for example, that would be something like y equals x squared or y equals negative x squared. If the a's are 1s, you're going to have what we call a medium bell shape. So if this is your vertex, automatically your first 2 points make a kind of triangle, and then it goes up from there. If it is going downward, there's your vertex. Again, the first 2 points make kind of a triangle with the corners of the graph paper, and then it comes down. So that gives you an immediate idea as to if your graph shape looks right. All right, second one. If a is greater than 1, and this would be the absolute value of a. So for example, y equals 2x squared, the 2 is greater than 1, or y equals negative 3x squared, absolute value of negative 3 is also greater than 1. So if it's basically a whole number, you're going to have a narrow bell. So, and it gets to be really hairpin-like really, really skinny, really, really fast. So you're talking really slender. All right, the last one is if the absolute value of a is less than 1, if it's a fraction. So for example, y equals 1/2 x squared, so a is 1/2, or y equals negative 3/4 x squared, where a is also a fractional value. So if a is a fraction less than 1, you're going to have a wide bell. And they get wide really, really fast. So you're going to end up with a super wide bell either opening up or opening down, and you need to make your graph accommodate the width that you can expect. All right, so last thing, just a reminder, is on your graph you need to label all points, as well as, so plus, the axis of symmetry. So vertex plus 2 pairs plus axis gives you a good graph. All right, that is everything. Have a good rest of your day.